turn off your video.
Video, sir. What,
Yes.
sir?
Just turn off your video.
Turn off the video. Should I put leave?
No, not leave. Just a video. Just turn off the video. Stop video. There is an option, right?
Stop video. Okay. Okay.
Yes. Unmute it. Yes. Thank you. Okay. So today we are going to see the contents. First of all, we'll try to understand your Newton's laws. So all the three laws we are going to discuss today. Okay. And after that, we'll discuss about the types of forces. First, we'll see the types of forces, then we'll see the Newton's laws. And after that, we are going to discuss about the types of units today. Types of units. So under these types of units, we are going to see the conversions also. So MKS to CGS conversions and as well as CGS to MKS conversions with the different physical quantities. Okay. And after that, we are going to discuss about your dimensions. So today itself, we'll see the dimension analysis. Dimension analysis, it will be in terms of your base quantities, that is your M, L, and T. We'll go step by step, one by one, we'll try to understand. If you have any difficulty, anything, any issue, please stop me there and you can ask me the questions. Okay, I'll turn off my video and we'll start. So last class, we are discussing about your law of conservations. Law of conservation, last class. So in this law of conservation, I told you there are four types out there. There are four types out there. First one, law of conservation. It is your, okay, please turn off your videos now. Okay, so law of conservation of your energy. First one, law of conservation of energy. Second one, law of conservation of charge. Third one, law of conservation of linear momentum. And fourth one, law of conservation of angular momentum. So we have discussed these four types in last class. So energy, charge, linear momentum, angular momentum, everything is almost similar. It depends upon the conservation. Conservation is nothing but energy or charge. It transfers from one form to other form, one form to other form, or one body to other body, and neither can be created, neither can be destroyed. Remember it. So energy neither be created nor destroyed, but it will transfer from one form to other form or one body to other body. Remember it. So these are the things we have discussed in last class. Okay. So now we are going to discuss about the types of forces. Can anyone tell me how many types of forces are there? If you remember it.
Four types.
Four types. What are they?
Gravitational force,
Okay.
electromagnetic force,
Okay.
strong nuclear force, weak.
Okay. Right. But what is pull and what is push? Are they forces or what? ಇದು ಬರಾದ countler. Okay. Remember, what is a force? Let me know what is a force. Hmm?
Force
Complete
is a
it.
push or pull.
Force is a push or pull. What is the unit for force, ma?
MLT power -2.
Unit, not the dimension.
Newton per meter square.
Newton per meter square is the unit for force. Correct? What is the unit for pressure?
So force by area is pressure.
Force by area is pressure. So force by area pressure is nothing but your Newton per meter square, or we can say Pascal, right? So then what is the unit for force? It is Newton alone. Newton per meter square. Pritam. Okay, va?
Okay, sir. Okay,
you have
sir.
to work out on these things. Okay, let's see. We'll try to understand your forces. Forces are of two types. Forces are of two types. So one is your contact force, one is your non-contact force. Contact force and non-contact force. Contact forces are under two types. One is your applied force. Applied force. Or we can say the muscular force. Muscular force. Applied force and solla, illana muscular force and solla. Second thing, we'll discuss about your frictional force. Frictional force. Okay, remember frictional force, we already know that it is nothing but your opposing force and solla. A resistive force and solla, or else we'll say it as opposing force. Remember it. Okay, so let's see. First of all, so when we are discussing about the muscular force, when we are giving a contact based on whether it is push or pull will be there. Okay, push or pull will be there in your applied force. That is nothing but your muscular force. So this is nothing but your force here. Can you please mute it, no? Please mute it. Yes, thank you. So this is your force one. So next one is your frictional force. That is nothing but your opposing force. Opposing force and சொல்லும்போது, so here it is nothing but your resisting force. For example, this frictional force depends upon two things. One, surface. So this topic we'll discuss in your laws of motion. Laws of motion நம்ம வந்து in detail பார்க்கணும். It is so much important. We can expect one question on this friction. So the friction depends upon the surface. Second one, the friction depends upon the weight of the object. Weight of object. Surface மேல depend ஆகும் as well as weight of the object மேல depend ஆகும். Remember, surface and weight. Surface and சொல்லும்போது, if the surface is rough surface. If the surface is rough surface. When you are placing an object on the rough surface, when you are applying some force, what will happen? A small amount of force apply பண்ணாலும், what will happen? It won't move at all. Okay. Same thing, when you are placing an object on the smooth surface, now the small amount of force apply பண்ணாலும், what will happen? It will try to move. Okay, because it is a smooth surface. So it depends upon the smooth surface and depends upon the rough surface, friction will be acting. On the smooth surface, almost the friction is zero. Friction is equal to zero. On rough surface, because of the roughness, so it will be interlocking between the object and as well as the surface. What will happen? So the object won't move easily. Okay, that means there is an opposing force acting on this object. So now on the applied force on the direction opposite to it, there is a frictional force acting on. Anyway, so just remember that friction force is nothing but your opposing force, or you can say the resistive force. Okay, it depends upon two things, surface and weight of the object. Okay, remember it. So next one is your muscular force. You already know about the push or pull. Push means again we are applying a contact. So because of the pushing, what will happen? The object is gaining an acceleration and it is moving. Same thing for pull also. When we are discussing about the pull, remember there is a pulling, and if we are discussing about that string பத்தி நம்ம டிஸ்கஸ் பண்ணும்போது there is a term called tension will be acting in the string, and it is directly related to your pushing forces. So this tension is also a force. The tension is acting in the strings. Strings la irukum illana on the wires la irukum. So force and tension both are same, both are having same units, which is nothing but your Newton. Okay, remember it. So these are nothing but contact forces. Okay, right. So let's see about your non-contact forces. So non-contact forces in the four types and so discuss பண்ணிருக்கோம். So Rahul சொன்னது கரெக்ட்டா, there are four types of non-contact forces are there. So the first one is your gravitational force. Gravitational force. Second one is your what is the second one, ma?
Electromagnetic.
Yes, ma. Good. Electromagnetic force. Third one.
Strong nuclear force.
Yes, ma. So we can say nuclear forces. Under nuclear forces, there are two things are there: strong nuclear force and as well as a weak nuclear force. So let's see one by one. So gravitational force on the we'll discuss in your gravity. So here this concept, okay, we are going to study about your capital G. Capital G is nothing but universal gravitational constant and so to term. We are going to study that. So capital G value is 6.67 into 10 power minus 11. Remember it. 6.67 into 10 power minus 11. And when we are discussing about the gravitational force, so this is nothing but your yeah. So this is nothing but your attraction between the planets, okay, or bigger masses. So all over the universe, the constant value will be same. It won't change at all. So assume, let us see. So assume I'm just taking two masses. Assume I'm taking two masses. So our two planets in solar. So here, this is your mass m1, this is your mass m2. These two are separated by small distance of r. These two are separated by small distance. Same thing in electrostatic law. There is a Coulomb's law. Similar to the Coulomb's law, this is also your non-contact force. So here, because of the fields are linked. So remember, this is your gravitational field. Because of the fields linking between these two masses, what will happen? They'll be having some forces acting on these two masses. These two forces will be same, but one with respect to two. And here, two with respect to one. Okay, both are same forces, and because of the same forces acting when the gravitational fields are linked with each other, what will happen? These two will attract with each other. Gravitational forces on the attractive forces mattum repulsive forces remember it. So the same relation, so it is a G is equal to, sorry, F is equal to G m1 m2 by r square. So we'll discuss again, there is a derivation for this under gravitation. Now on the detail of our So here when we are discussing about the capital G what a unit of the, so it is a G is equal to, it is a Newton meter square per kg square, and we know the value of capital G. Okay, remember it. So and in this case, when we are discussing the forces, remember these forces there is a wide ranges. Remember, so this force will be acting in wider range. We are discussing in with respect to your planets based on discuss and there are forces acting here. Forces because it is a wide range and it is in the universe. So here the ranges will be a wide range of forces will be acting between the planets. So let's see about the electromagnetic forces. So these electromagnetic forces related to your charges, okay, and as well as magnetism. I'll split this electromagnetic force into two types. One is your electricity and one is your magnetism. One is your electricity, one is your magnetism. Under electricity, we are going to discuss about two things. So one is your electrostatics and one is your electrodynamics. Electrostatics, you already know, this is your first chapter and second chapter. Okay, and electrodynamics is nothing but your current electricity. And again, magnetism will be there. So moving charges. So here itself, electromagnetic force related to your class 12, almost on the 3 to 4 chapters linked. Under electrostatic, again, you are going to discuss about the Coulomb's law. You already know the relation. So two charges. So suppose these two charges are same charges. In Ago, it will try to repel. Opposing forces will be acting, repulsive forces. Okay, are they on the opposite charges? It will try to attract. Again, attractive forces act. So here again Coulomb's law will be there. These two are separated by small distance of r. Of Coulomb's law, F is equal to, it is a K Q1 Q2 divided by r square, where K is your proportional constant. This proportional constant value is 9 into 10 power 9 when you're placing in vacuum. When you're placing in any medium, depends upon the medium, there is a term called mu r will be acting on. This is your force. Okay, same thing for your magnetism also. Under magnetism, we are going to discuss about the pole strengths of the bar magnets. Assuming I'm just taking two bar magnets. So this is your north pole and this is your south pole. These two poles, okay, so here this is your bar magnet. Okay, bar magnet is similar to your dipole. Remember, bar magnet is similar to your dipole. Now from the center, it will be equally splitted and it has its own two different poles. So here, this end we call it as pole strength. We'll discuss about the pole strength, and this bar magnet is nothing but your dipole. It is your dipole. So here again, these two are separated by a small distance of r. Again, there is a Coulomb's law here. So the force is equal to some proportional constant. In the proportional constant value, it is 4 mu naught by 4 pi into. So in the pole strength, I'll specify it as a Qm1, Qm2 divided by r square, where Qm1, Qm2 are your pole strengths of your bar magnet. Pole strengths. Again, on the attractive force and as well as repulsive forces. Again, it is nothing but your non-contact forces. Okay, now that is your nuclear forces. Nuclear forces now there are ranges on this smaller, least ranges are so it will be attractive or repulsive. It will be atom level. Remember it. So first of all, we'll discuss about the that is a strong nuclear force. Strong nuclear force, it will be there between your nucleus. So nucleus and solubod, you know that atom and solubod, there will be a nucleus and there is an electron revolving around it. Nucleus consists of your proton and neutron. So nucleus consists of proton and neutron. Remember, the proton and neutron are combined together. We cannot able to split it. So the attraction between proton and neutron is so strong, which we cannot able to split it. It is there in your Dalton's atomic theory. Okay, so on the concept there. So we cannot able to split it. So this force we call it as strong nuclear force. Nuclear means the smallest particles here. Okay. So weak nuclear force na emission and losing of electrons here. So adu vandu neenga decays lo discuss panni. So this is nothing but your strong nuclear force and weak nuclear force. Just remember it. These are your non-contact forces. Anyway, no need to take it. Just remember these cases. And the concept lo varumbodhu we'll discuss again in detail. Okay. So these are your forces. Now we'll discuss about your Newton's laws. Can anyone tell me what are the statements of your Newton's laws? All the three laws? Statements alone. Not much more than that. Derivations 11. I know loss of motion. Derivations.
Every reaction has an opposite and equal reaction.
Every action has an equal and opposite reaction. Okay, good. Okay. Is it a first law, second law, third law?
Third law.
Third law. Good. Okay. What about the first law?
Body continues to the body continues to remain in a state of inertia unless an equal opposite force
acting on it. Super, no. Good, no. Good. Let's see one by one. So I'll give the statements directly. So Newton's laws, there are three laws out there. First law, we call it as a law of inertia. Law of inertia. First law we call it as law of inertia. Second law we call it as law of momentum. Law of momentum, or we can say it as a change in momentum. Change in momentum. And the third law we call it as a law of reaction. Law of reaction. Let's see. So there are statements number. So let's see the first law. So I'll write here first law. In this first law, so a body at rest, body at rest will remain at rest, okay, and a body, okay, in motion will remain in motion. So remain in motion and சொல்லும்போது it has its own constant velocity. Okay, remember remain in motion சொல்லும்போது constant velocity la movement இருக்கும். Constant velocity. Okay, so unless acted upon by a unbalanced force. Acted upon by unbalanced force. Okay, this is your law of reaction. That means ஒரு ஆப்ஜெக்ட் நான் எடுத்துட்டு இருக்கேன்னா இந்த ஆப்ஜெக்ட் வந்து ரெஸ்ட் கண்டிஷன்ல இருக்கலாம், இந்த ஆப்ஜெக்ட் வந்து மூவ்மெண்ட்ல இருக்கலாம். Remember, let's see for example. So assume this is your surface. I'm just placing an object. So it has its own mass. Remember, mass இருந்தாதான் என்ன ஆகும்? There is a force acting on it. Mass இல்லைன்னா there is no forces. In the object வந்து it will be at rest condition, or the object may be under motion. That means constant velocity ல இருக்கும். Why constant velocity? Na there is no acceleration. Acceleration எப்போ இருக்கும்? When there is a force acting on this object. Okay, constant velocity, the acceleration A is equal to 0. So this object will be at rest condition or under constant velocity. So that means we call it as inertial object. These are nothing but your inertial objects. Inertial objects and சொல்றோம், or inertial bodies and சொல்றோம். Okay, so until unless external forces are needed. External forces and சொல்லும்போது these should be unbalanced forces. So இங்க வந்து two types of forces இருக்குமா. So balanced force இருக்கு, unbalanced force இருக்கு. So we'll discuss this balanced force, unbalanced force again in your laws of motion. But try to understand balanced force now. So the net force is equal to 0. The net force acting on the body is equal to 0, and acceleration Hello, can you able to hear me?
Yes, sir.
Yes, ma'am. Sorry.
Yes, sir.
Network issue. Okay, so we'll continue. So now earlier we are discussing about your inertia, law of inertia on the object on the rest condition. It doesn't move at all until unless external forces acting on it. That is your law of inertia. So in the law of inertia law, there are types are there. There are three types are there. So inertia at rest, inertia at motion, and inertia at direction. Inertia at rest, inertia at motion, and inertia at direction. These are the three types of inertias are there. So first of all, inertia memorize பண்ணிக்கோங்க. Inertia is nothing but any object which it is not moving until unless external forces acting on it. So that means acceleration வந்து அங்கே 0 ஆயிருக்கும். Remember it. So இங்க வந்து inertia at rest ன்னு சொல்லும்போது, so if you keep a body whatever the object is there, if you keep a body at rest, at place, it remains there only. Okay, it doesn't change its direction, it doesn't change anything, its motion and direction, edume change agadu. So the body will be at rest only. The body will remains rest only. Remains at rest until and unless external forces acting on it. This is nothing but your inertia at rest condition. Remember it now. Same thing, motion. So when you're discussing about the motion, so for example, when you're sitting in your bus, for example, when you're sitting in the bus, so here there is a contact between the bus and as well as that is your seat and as well as you. So when the bus suddenly starts, you can able to feel the motion. So until and unless external forces on it acting on your body or acting from the bus towards you, what will happen? You will be at rest condition only. So until forces acting on it, forces acting, so we will be at rest. We are at rest condition. So this is nothing but your motion. So if there is any external forces acting on it, what will happen? Then there is a motion. At the forward irukla, back to irukla. That is nothing but your motion. Same thing for direction. So chinna example. Assume you are standing in your bus, for example. If you are standing in your bus, if the bus moves towards your right side, what will happen? Your body will try to move towards your left side. So there is an equivalent opposite reactions. Again, it satisfies your Newton's third law. Okay, so every action has an equivalent opposite reaction. This is nothing but your direction. So or object on the when it is moving towards your right side, other equivalent opposite reaction will be there towards your left side. So this is nothing but your inertia. Okay, and there is one more thing: non-inertial objects. Non-inertial objects now without any forces acting on it, what will happen in the object on the move? Like ourselves. So here we are moving ourselves without any forces acting on us. So we are non-inertial objects, non-inertial bodies. Okay. So remember this case. This is your first law. Okay, Newton's law, and this is nothing but your law of inertia. Let's see the second one. Second one, we call it as your change in momentum and or law of momentum and So law of momentum. So let's see, I'll give the statement for it. So in this case, so the magnitude of net force, acting on a body is proportional to the product of mass of the body, okay, and its acceleration. So the direction of the force is the same as that of acceleration. Remember it. So the magnitude of the net force acting on the body is proportional to the product of the mass of the body and its acceleration. So here let's see the relations. It is nothing but your momentum based panni da நம்ம discuss பண்ணிட்டு இருக்கோம். We'll see a small example. So the relation on the so that means so the magnitude of net force. So here, so the magnitude of net force, that means the force is directly proportional to the product of mass and the body and its acceleration. Product of mass and the body of its acceleration. So force is directly proportional to mass into acceleration. Okay, the direction of the force is in the same direction of acceleration. This is your relation. But remember, when we are discussing about the momentum, let's say an example. So assume I'm just taking an object. So to understand this Newton's second law, so I'll take an example. I'm just taking an object. So object, remember law of conservation, mass vary agadu. Mass will be always constant. Mass doesn't vary at all. Okay, so mass will be always constant. So in this case, this is your mass. Okay, so when we are applying some force, remember when we are applying some force, what will happen at that instant? It will gain some velocity. This is your initial velocity, and the object in the move, and assuming this is your A point, and here it is your I'll take this one as B point. mass is constant because of the force initial point and the final point move. I'll take this one velocity as initial velocity, I'll take this one as final velocity. So there is a displacement here and there is a time period here, remember it. So that means initial momentum, I'll take this one as p1, here there is a momentum, I'll take this one as p2. So force act பண்ணும்போது there is a change in its momentum. So we can say that force is directly proportional to your change in momentum and it is varying with respect to time period. So we call it as force is directly proportional to the rate of change of momentum. One more example for this. Okay, there a definition we can say it as force is directly proportional to, okay, a rate of change of momentum. Rate of change of momentum. In the rate of change of momentum, the acceleration. Let's see. So இங்க வந்து momentum ன்னு சொல்லுவோம். So I can rewrite the relation as force is directly proportional to dp ன்னு சொல்றோம். So that means it is varying. The difference we are going to find. So it is a p2 minus a p1 divided by your t2 minus t1. Remember it. So time period வந்து vary ஆயிட்டு இருக்கு and இதோட momentum change ஆயிட்டு இருக்கு. So this relation இங்க இருந்து தான் நம்ம வந்து f is directly proportional to or f is equal to mass into acceleration ன்னு சொல்லிட்டு we are going to extract it. Okay, remember this relation. This relation மட்டும் ஞாபகம் வச்சுக்கோங்க. இந்த கேसेस வந்து நம்ம laws of motion இன்னும் டீடைலா நம்ம பார்க்க போறோம். There are so many relations are there. Derivation இருக்கு, impulse ன்னு சொல்லிட்டு ஒரு கான்செப்ட் இருக்கு. நம்ம அங்கே பார்க்கலாம். So first law is nothing but your law of inertia, second law is nothing but your change in momentum. So the change in momentum, or we can say the rate of change of momentum is directly proportional to your force here. Okay, remember this. This is your second. Any doubt so far? Any doubt? Hello?
No, sir.
Okay, others? ஏதாவது கொஞ்சம் ரெஸ்பாண்ட் பண்ணா நல்லா இருக்கும். Okay, good. So let's see next one. So we are going to discuss about the third law. So third law it is nothing but every action has an equivalent opposite reaction. You already know that every action has an equivalent opposite reaction. Okay, so action reaction பத்தி தான் நம்ம டிஸ்கஸ் பண்ணிட்டு இருக்கோம். Action and reaction. ஒரு சின்ன example then we can stop this topic and we'll start your units. Okay, so let's see, for example, assume I'm just assume there is an object, either a horizontal surface. For example, there is an object. Okay, so object, it has its own mass. It has its own mass. Okay, so when the object is moving with some force acting on it, it will gain some acceleration, and the acceleration direction the object move ஆயிட்டு இருக்கு. Okay, object இல்லனா vehicle, remember it. So when it stuck to the wall, when it hit the wall, what will happen? It will bounce back. Remember, when it hit the wall, it will bounce back. When it is bouncing back, so whatever the action it is giving, so bouncing back by hitting the wall is nothing but your reaction here. Okay, one more example. Assume we will discuss about the weight, right? So assume I'm just placing the object, a mass which has its own mass, so on the horizontal table. On the horizontal table, when you're placing the object on the horizontal table, remember, so now ஒரு force apply பண்றேன், upward direction ஒரு force apply பண்றேன். When you're applying some force, this is nothing but your action. This is nothing but your action. So when applying some force, what will happen? From the table, again, because of the contact, what will happen? Or a reaction act ஆயிட்டு. Okay, so the reaction will be upward direction. So this is your reaction from the table. This ball with some force on the wall, what will happen? It will try to bounce back. What are the force I'm applying here? With the same force, it will try to bounce back. If it is an elastic object. So every action has an equivalent opposite reaction. So it will hit the ball. I hit the ball, what will happen? It will bounce back. This is nothing but your action and reaction. Every action has an equivalent opposite reaction. This is nothing but your Newton's third law. Okay, remember these cases. இதுல வந்து நிறைய conditions இருக்கு and நிறைய derivations இருக்கு. We'll discuss in your laws of motion. Okay, so let's see. Now we are going to start your unit. இதெல்லாம் வந்து நான் discuss பண்றது why? Because you remember this one, you may get questions on these small topics. Okay, chinna topics so you may get questions. Remember it. Don't forget these things. I can ask you anytime. Okay, even end of the courses on the questions about the Newton's laws, about the forces. There's some examples on the definitions, on the relations. You have to remember these things. You have to explain those. Okay, right. So we'll try to understand. So in this case, so here now we are going to discuss about your relations, that is your units. So we'll try to understand your units. So in these units, before going to the units, we'll try to understand what is physics. Can anyone tell me what is physics? And physics, how it has been split?
Physics is the study of natural things.
Study of the natural things. Yeah, we can say physics is nothing but the study of natural phenomena that occurs in the universe. We can say that. Good. So it is your natural phenomena that occurs in the universe. Phenomena that occurs in universe. In universe. Okay, remember this question. Now physics வந்து எத்தனை பார்ட்ஸ்ல ஸ்ப்ளிட் பண்ணிருக்காங்க தெரியுமா உங்களுக்கு? How it has been splitted? Anyone? Okay, so it has been split into 4 parts. It has been split into physics concepts. It has been split into 4 parts. One is your classical mechanics. One is your classical mechanics. Okay. Second one is your thermodynamics. Second one is your thermodynamics. And the third one is your electromagnetism. Third one is your electromagnetism. And fourth one is your modern physics. Fourth one is your modern physics. Remember this one. So either it has been split into 4 types: classical mechanics, thermodynamics, electromagnetism, and as well as your modern physics. Modern physics, it explains your theories, other proposals related to your nuclear. So we can say modern physics is similar to your nuclear physics itself. Again, we are going to discuss about the special relativity. Special relativity. இதெல்லாம் வந்து நம்ம just for your understanding, just for your knowledge, that's it. So quantum mechanics, and we are going to discuss about the general relativity. General relativity. So these are your terms where physics has been split. Remember it. So and when you are discussing about the classical mechanics we study the motion of the particles. Study the motion of the particles. Motion of particles. Motion of particles. So the particles and as well as fluids also. Fluids also. So fluid mechanics fluid mechanics, properties of fluids, the fluid mechanics. So that one also we are going to study. So and when we are discussing about the thermodynamics only deals with the study of temperature. Deals with the study of temperature, heat transfer, heat transfer. Okay, and as well as the properties of your many properties are there. There are so many expansions are there because of the heat transfer. Okay, expansion patti நம்ம discuss பண்றோம் இதுல. And the material expansions. Okay, and next one is your electromechanism. Electromechanism, it deals with your electricity part, deals with your magnetism, and it deals with your electromagnetic waves. Okay, so these are few things, and as well as your wave optics also. Electromagnetism we discuss. So modern physics, you know that it is your behavior of your sub-microscopic level. Okay, we can say it as a microscopic level or microscopic world particles. Microscopic world particles. Okay, nuclear physics patti we discuss. Okay, so these are your splitting of physics. Remember, just for your case, just for your understanding. Now when we are discussing about the forces, இது முன்னாடி நான் forces சொல்லிருக்கேன், 4 type of forces சொல்லிருக்கேன். இதுல வந்து எது strong, எது weak, and what is the ranges, we'll see that. Okay, so let's see, make a table column here. So forces நம்ம discuss பண்ணிருக்கோம், and the forces based பண்ணி, and which one is stronger. So we are going to discuss about the relative strength of that particle, and as well as we'll discuss about its range. I'll write at the top. And we'll see the range. Okay, so let's see. Make a small table column here. The first one is your force. That force is your strong force. Strong. Next one is your electromagnetic force. Next one is your weak force. Next one is your gravitational. And the strong and solution, that is nothing but your strong nuclear force. Remember, that is your strong nuclear force. So second one is your electromagnetic force. Third one is your weak nuclear force. Fourth one is your gravitational. This is your sequence of forces. And there are strengths based on discuss pannabodu. So the relative strength is stronger. So it will be 1. There are ranges on the 10 power minus 15 meters because it is so small, right? Now already said these are your so small ranges. 10 power minus 15 meters. So next one is your electromagnetic forces. So it ranges, so it is less than the strong nuclear. So it is 10 power minus 2. There are range on the infinity work, infinite. Okay, and a weak nuclear force it is a 10 power minus 6. And either range we'll discuss it as 10 power minus 17 meters. 10 power minus 17 meters. And the gravitational force on the 10 power minus 38. And here it is infinite. I told you it is very vast and it will be spread all over the universe. So please take this tabular column now. Or
Sir, MTGல வந்து weak nuclear force relative strength 10 power minus 13 கொடுத்திருக்கு சார்.
10 power minus
13.
30.
13 சார். minus 13.
13. நம்ம மேக்ஸிமம் தான் நம்ம கொடுக்குறோமா அதுக்கு. நம்ம மேக்ஸிமம் பாயிண்ட் தான் நான் கொடுத்துருக்கேன். So it may can vary. So அதுக்குள்ள இருக்கும். Remember this range is your at maximum point. இது மேல வரைக்கும் இருக்கும். So this is infinite. Infinite வந்து maximum point. 10 power minus 15 வந்து maximum point. Okay, இதுக்குள்ள வரைக்கும் நம்ம வந்து சொல்லிக்கலாம் ranges. புரியுதா உங்களுக்கு? Over. Is it over?
Over, sir.
Yeah. Others? கொஞ்சம் நீங்க மெசேஜ் பண்ணுங்க. நீங்க சப்போஸ் பேசலனாலும் பரவாயில்ல. Just message me.
Over,
Yes
sir.
or yes. Okay, good. Okay. Right. So let's see next one. So now we're going to discuss about your units. So units. Okay. Can anyone tell me what is a physical quantity and what is a unit? Are they both same? So what is a physical quantity? Anyone?
It's like mass. It's a standard unit of mass.
No. எல்லா இதுக்கு mass length time ன்னு சொல்லிட்டு ரிலேட் பண்ண முடியாது. So those are physical quantities. I mean to ask you, what is a physical quantity? What it means actually, physical quantity. All quantities can be measured or physical. Good, we can say that. Okay, right? So actually physical quantities, so which we describe the law of nature. Okay, which we describe the law of nature, which we describe the law of nature, and which can be measured, and which can be measured, okay, are your physical quantities. So the measure பண்றதுக்கு we required some element. That elements are nothing but your units. Remember it. Okay, so in the physical quantity measure பண்றதுக்கு we require some device and சொல்லலாம், some instrument and சொல்லலாம். Those are nothing but your units. Okay, so in the physical quantities it has been split into two things: fundamental quantity and as well as your derived quantities. Fundamental quantities and as well as your derived quantities. So fundamental quantities, these are your basic physical quantities. These are your basic physical quantities. Physical quantities. Derived quantities, so those are deriving from the fundamental units. Derived from fundamental quantities, we call it as derived quantities. Okay, remember it. So let's see, we'll try to understand your units. So this is just basic relations. Now units are the main concepts. So units, I'll split it as 4 types. Remember, units now 4 types are split panikom. So here one is your MKS, second one is your CGS, third one is your FPS, fourth one is your SI. Okay, so MKS, CGS, FPS and SI. Okay, so MKS, let's see. So MKS is meter, kilogram, second. MKS means meter, kilogram, second. CGS means centimeter, gram, second. CGS means centimeter, gram, second. And FPS is foot, pound, second. Foot, pound, second. You already know that. So I'm just explaining it. So meter, centimeter, foot are for your length measurement. And kgs, grams, pound for your mass measurement. And seconds for your time measurement. Okay, so meter, kilogram, second. So length, mass and time. This length, mass and time, these are your basic physical quantities. I told you, right? These are nothing but your fundamental units. These are nothing but your basic physical quantities. So these are the 3 types. So that is length, mass and time. So now we are going to discuss about the SI unit. We call it as International Standard Unit. In the International Standard Unit, it's split into 3 types. It splits into 3 types. One is your fundamental unit, one is your derived unit, and one is your supplementary unit. I'm using shortcuts. Please note it down, that one. So fundamental unit, derived unit, and supplementary units. Remember it. So fundamental units are of 7 types. Fundamental units are of 7 types. 7 types. Okay, so let's see one by one. So first one is, I told you, right, the base quantities. That is your length. Second one, mass. And the third one, time. In the base quantities change. In the base quantities or units, I'll take it as your MKS format. That is your meter, kilogram, and second. Length is your meter, so mass is your kilogram, and time is nothing but your second. Okay, remember it. So now fourth one, I'll take it as temperature. Fourth one is temperature. And the fifth one, your luminous intensity. To measure the light, we are saying it as luminance. That brightness measure pandradhukku. So we are using a device, candela and sollte the unit. The unit is candela. To measure the light, we say the term as luminous intensity. So the unit is candela. Sixth one, your mole, that is your amount of substance. It will be there in your chemistry. So the unit for amount of substance is mole. And the seventh one, current. Current oda unit on the ampere. You already know it. So these are your 7 basic fundamental units, and these are your 7 basic physical quantities also. Okay, temperature, the unit is your Kelvin. unit is your Kelvin. But apart from the Kelvin, there are two different units are there: degree Celsius to Kelvin and degree Celsius to Fahrenheit. You remember anything about the conversions, degree Celsius to Kelvin and degree Celsius to Fahrenheit? Anyone?
Degree Celsius to Kelvin is actually plus 273.
Yes, ma, good. So plus 273. Okay, so we can convert that into Kelvin. Good, ma. So we can convert that. So 273 plus degree Celsius is nothing but your Kelvin. And Fahrenheit convert pannomna. So it is a 9/5 into degree Celsius plus 32. This is your minus, no minus, no plus. So 9/5 degrees Celsius plus 32 is your Fahrenheit conversion. Okay, these are your fundamental units. And what are the derived units which you are going to see now? So those are all derived units. All are step by step. Please take it now. And remember one more thing, when we're discussing about the FPS, foot pound second வந்து இது பிரிட்டிஷ் ஸ்டாண்டர்ட்ஸ் பேஸ் பண்ணி தான் நம்ம வந்து எக்ஸாக்ட் பண்றதுனால we are not going to use it. So நம்மளுக்கு வந்து FPS ரிலேஷன்ஸ் வராது. Only MKS and CGS conversions மட்டும்தான் நம்மளுக்கு வரும். And when there is a வந்து we'll consider this as SI units. Remember it. MKS now it will be under length, mass and time alone. Okay, CGS na centimeter, grams and seconds. When there is a SI unit, like for example Newton and சொல்றோம். Force வந்து one more unit is there, kg meter per second square. This kg per meter per second square, this is your MKS. Newton is your SI unit, international standard unit. Okay, authorized international standard unit. MKS lo Newton இது. அதே வந்து CGS ன்னு சொல்லும்போது gram centimeter per second square. This one under CGS SI we call it as dyne. In the மாதிரி there are different names are there, different units are there. We are going to see the conversion. Now, please take it. இது நோட் பண்ணிக்கோங்க, make it fast. What? That just reply me. If it is over, then we'll go to the next one.
Sir, over, sir.
Okay, ma'am. Good. Right. So let's see. Rahul, Reena, or Preetham, what about you?
Over, sir. Over, sir.
Yeah, ma'am. Okay, good. So now we'll try to understand your what I'll do. So for your understanding, நான் வந்து இங்க பக்கத்துல note பண்ணி வச்சிருக்கேன். So the fundamental units are of 7 types ன்னு சொல்லிருக்கேன். I'll write here. Then we'll do the derived units. So first one is your length. So mass, time, temperature. So it is your amount of substance, luminous intensity, and your current. Okay, length is meters, kgs. So this is your second. Temperature Kelvin, amount of substance is mole, luminous intensity candela, and current is ampere. So third, fourth, fifth, sixth, and seventh. These are the 7 fundamental units. Right. So let's see. Now we are going to discuss about your derived units. Derived units, So we'll take some examples. So I'll take some examples. Or examples based on we'll try to understand. So you already know. உங்களுக்கு தெரிஞ்ச quantities நான் எடுத்துப்பேன். So like for example, first one, I'll take velocity. I'll take over 5 to 6 வந்து நான் physical quantities எடுத்துக்கிறேன். These are nothing but your physical quantities. Remember, velocity is your physical quantity. Second one, acceleration. Acceleration. Third one, momentum. Third one, momentum. Fourth one, force. Fifth one, pressure. So I got a few physical quantities, which you already know, a basic physical quantities. Okay. So physical quantities, and we are going to discuss under derived units. Remember. Now, this is physical quantities. Now we are going to see its relations. Relation check relations are. Now let's see. So velocity and so on, we know the relation displacement by time period. Acceleration is nothing but your velocity by time period. Momentum is nothing but your P is equal to mass into velocity. This is your relation. And force and so on, it is nothing but your mass into acceleration. Pressure is nothing but your force by area. Okay, these are your relations. Remember, what are the physical quantity they are asked in your problems. This based on your question compulsory. Remember it. So, இங்க வந்து relations based பண்ணி you have to extract its units. ரிலேஷன்ஸ்க்காக நீங்க ட்ரை பண்ணுங்க. ஸோ ஏதாவது ரிலேஷன்ஸ் இருக்கு, ஏதாவது வந்து கண்டிப்பா இருக்கும். ஸோ தேர் ஒரே பிசிக்கல் குவான்டிட்டிஸ்க்கு தேர் ஆர் சோ மெனி ரிலேஷன்ஸ் இருக்கும். ஓகே, ட்ரை டு அண்டர்ஸ்டாண்ட். அதே ஃபார் எக்ஸாம்பிள் வந்து இப்போ ப்ரெஷர் சொல்றேன். ஐ டோன்ட் நோ அபவுட் த ப்ரெஷர். ப்ரெஷர் இஸ் நத்திங் பட் யுவர் ஃபோர்ஸ் பை ஏரியா. ஓகே, ரிமெம்பர் இட். ப்ரெஷர் சொல்லலாம். ப்ரெஷர் இஸ் இன் ஃப்ளூயிட்ஸ். ரிமெம்பர், ப்ரெஷர் இஸ் இன் ஃப்ளூயிட்ஸ். இதே ப்ரெஷர் ஐ கேன் சே இட் அஸ் ஸ்ட்ரெஸ் ஆல்சோ. Stress in solids. So both are having same relations. Let's see that. So there are units. Units. So I'll write here in two types of units. One is your MKS and one is your CBSE. So what you'll do, just take down as a tabular column. Tabular column madri neenga note pannittu try pannunga. So MKS units. So S is nothing but your displacement. Displacement is nothing but your meter. That is your length measurement. So I'll take it as meter and the time is your seconds. Remember, so MKS or a unit on the meter per second. Meter per second is a unit for your velocity. Again, it is extracted from your fundamental units. Fundamental unit and the extract pannita have given the relation for your physical quantity. So these are your derived units. Remember, acceleration. So again velocity by time, again velocity fundamental unit. So acceleration also it is extracted from your fundamental units. So it is a meter per second square. Okay, and momentum is nothing but your mass into velocity. Mass is your kg, velocity is nothing but your meter per second. Okay, this is your MKS. So force, நான் நியூட்டன் பத்தி நான் சொல்ல மாட்டேன். Presently try to understand. Here we are going to discuss about the MKS and CGS alone. நான் SI unit பத்தி நான் பேசல. When we are specifying about the SI unit, then we'll discuss about your newtons or dyne. Now I'll write in terms of your MKS. It is kg meter per second square. This is your force unit. Pressure, force by area. Force another, it is kg meter per second square. Per second square on the I can rewrite the relation as s power minus 2. Kg meter s power minus 2 divided by area. Area is nothing but your length into length. Okay, length square, that is nothing but your meter square. Meter square, meter will get cancelled. So the relation is kg. It on the denominator, when I shift it, it will be inverse. So kg meter inverse second power minus 2. This is your relation. Remember, this is your pressure, stress, both are having same units. Okay, let's see velocity. See, yes, it is a centimeter per second. Time period won't change. Okay, remember. So adhe madri it is centimeter per second square. Inge it is grams centimeter per second. So force is nothing but your gram centimeter per second square. And the moment that is your pressure relation on the it is a grams centimeter inverse second power minus 2. These are your MKS and CGS units. Okay, so we have to go in this manner, like this step by step, and you practice panna, it will be very easy. Okay, so now I'll give 5 more physical quantities. Neenga vandu idhe maadhiri relation naane kuduthurren. Try to find the MKS and CGS. First one, torque. First one, torque. Second one, impulse. Second one, impulse. Third one, electric field. Electric field. Okay, fourth one, work. That is your, I'll take it as energy, kinetic energy. Kinetic energy. And the fifth one, I'll take it as power. So these are your known physical quantities for you. Okay, so these are your physical quantities, and I'll give the relation. You just extract the units from this. Okay, but you have to make it fast now. So torque relation on the force into perpendicular distance, force into your distance. Impulse is nothing but your force into time period. Impulse வந்து நம்ம என்ன சொல்றோம்னா the maximum time period for a shorter distance. Sorry, maximum force for a shorter time period. Maximum force for the shorter time period we call it as impulse. Electric field வந்து there are two relations are there. So நான் வந்து the work relation base பண்ணி இருக்கு and as well as velocity base பண்ணி இருக்கு. So remember electric field relation வந்து so I'll take the relation as force E is equal to F by Q இருக்கு. Electric field E is equal to F by Q இருக்கு. So F you already know, Q is nothing but your charge, that is your coulomb. But you should not say the coulomb here. Okay, remember you have to convert this in terms of your physical quantities, that is your fundamental unit. So I can write the relation as, so F is equal to, I is equal to Q by T. So Q is equal to I into T. So I into your time period T. Okay, this is your relation for electric field. And kinetic energy, you know that is your half mv square. Power is nothing but your work by time. These are your relations. So if I asked you anytime, try to understand that relation unit there is some difference here. Okay, if I ask you what is the unit for momentum, no, don't say mass into velocity. Mass into velocity is a relation. Unit is kg meter per second. Or you can say the relation with respect to your force also. Okay, right. So try to find the units, MKs and CJs. Please take a table column, step by step. And what I'll do, I'll send you a screenshot to you people. So on the screenshot, you practice. This is your homework. But you have to practice it. Every day you'll be having your work. Okay, once the chapter completes, you'll be having your test. Compulsory. So if you really don't want it, no, just stop it. No issues. It's up to you. Okay. So please take it, try to solve it. It's your homework, ma. Note பண்ணிக்கோங்க. So I'll give the work to you. So now share பண்றேன் உங்களுக்கு with the answers இருக்கு. So with answers இருக்கு. That means அதோட unit சேர்த்து இருக்கு. I'll share to you. Please do practice it. Don't miss it. Any doubts so far? Any doubts?
Sir, finished, sir.
Okay, good. Ma.
சார் இதுக்கு டைமென்ஷன்ஸ் எழுதணுமா சார்?
நான் டைமென்ஷன்ஸ் பத்தி நான் பேசல. டைமென்ஷன்ஸ் வந்து we'll discuss in next class. நாளைக்கே பார்த்துக்கலாம். ஓகே, இப்போதைக்கு வந்து நீங்க யூனிட்ஸ் மட்டும் பிராக்டிஸ் பண்ணுங்க. ஓகே, I shared you a screenshot to you. ஓகே, அதுல வந்து around 10 to 15 யூனிட்ஸ் இருக்கு. ஸோ அந்த யூனிட்ஸ் வந்து நீங்க எக்ஸ்ட்ராக்ட் பண்ணுங்க. அதுல வந்து வித் ஆன்சர்ஸே நான் கொடுத்துட்டேன். பட் ப்ளீஸ் டூ ப்ராக்டிஸ். டவுட் இருந்தா யூ கேன் ஆஸ்க் மீ இன் த நெக்ஸ்ட் கிளாஸ். ஓகே, வில் கோ ஸ்டெப் பை ஸ்டெப். ரொம்ப ரஷ் பண்ண வேண்டாம். உங்களுக்கு தெரியும் இந்த கான்செப்ட்ஸ் எல்லாம் உங்களுக்கு தெரியும். பட் ப்ராக்டிஸ் இல்ல. ப்ளீஸ் டூ ப்ராக்டிஸ். நான் வந்து இப்போ ஈஸியா பண்ணிருக்கேன். நாளைக்கு கிளாஸ்ல வந்து when you're doing the physical quantities அது வந்து கொஞ்சம் டிஃபிகல்ட்டா இருக்கும், டஃபா இருக்கும். நம்ம வந்து கெப்பாசிட்டன்ஸ், ரெசிஸ்டன்ஸ் அண்ட் டென்ஷன், ஸ்ட்ரெஸ், விஸ்காசிட்டி, there are so many stuffs out there. We'll discuss those things. கொஞ்சம் டிஃபிகல்ட்டா. So that time we'll discuss about your dimensions. Okay, right, good. So we'll see you next class then. Okay, please do practice it. Don't miss it. Okay, right, ma. We'll see you tomorrow. Tomorrow at 3 o'clock.
Okay.
Bye, sir.
Right, ma. Bye, ma. Bye.
Thank you.
Bye.